how does the sorting function? What's the purpose of the object? Second thing is programmers do not consider the cost of polymorphism. There's an alarming number of programmers who cannot fully explain the cost or how the virtual or abstract keyword in Java works. They have absolutely no idea how it works. It just does, right? And in the C++ world, static polymorphism is often the culprit of incredibly long compilation time issues and compiler reviews. Education on algorithms and data structures is kind of done in a vacuum. Big O notation is often treated as a performance metric, which is very strange to me. Because complexity and performance are not the same thing in the real world. They're completely different ideas. Runtime characteristics across different hardware is what you want to look for in performance, right? Complexity just gives you kind of a general idea of how an algorithm will grow over time, right? And the behaviors and the attributes of those data sets that you're transforming with whatever it is you're doing have a direct impact on the performance. And finally, there's this kind of misguided focus on code. We're always talking about the code, right? It's like, oh, I can make this algorithm, I can make it do this, when the vast majority of the time, the code is not the issue. What the issue is data. Data has the most material impact on the runtime of software, not the code. So let's talk about what data-oriented design is. What is it that I mean, okay? So I talked about object-oriented programming, some of the problems with it, but what is data-oriented design? So the first thing about data-oriented design is this. The purpose of all programs and all parts of those programs is to transform data from one form to another. This is not a belief, right? I didn't just make this up in my big brain, right? This is the point. This is the entire point, right? You have data, it's not very meaningful, and you want to make it into something that is meaningful, right? So to that end, if you don't understand the data, you don't understand the problem, right? And by the way, these are rules that were came up with Mike Acton. These are not my own thoughts. So if you don't understand the data, you don't understand the problem, right? If you don't understand the data you're transforming, and by data, I mean data that is materially relevant to what you're trying to achieve, you don't understand the problem. So therefore, if you have different data, it requires a different solution, right? You cannot make a solution that's independent of the data. That's honestly a act in futility. So if you don't understand the cost of solving the problem, you don't understand the problem. So if you cannot reason about what the cost of solving a problem is, you don't fully understand the problem. And if you don't understand the hardware, you cannot reason about the cost of solving a problem, right? Software is a real thing. It has to run on hardware, right? So if you don't understand the hardware, how could you possibly reason about the cost of solving a problem? And finally, everything is a data problem. Everything. Maintainability, debuggability, usability, they're all data problems. Everything is a data problem. So some rules of thumb in data-oriented design. This one I love. Solving problems you probably don't have creates problems you definitely do, right? So this is the idea of like introducing abstraction when you have no need for it. Another rule of thumb is that when there's one, there are many. You have to look at the time axis. So what I mean by this, very often I see people write functions that it acts on one object, right? When was the last time you wrote a big program where there was only one object that needed transforming? You didn't, right? There's tons of objects we're dealing with, right? So you want to write stuff that takes care of many, the most common case, that there will be many objects. The more context you have for a solution, the better the solution will be. And I'll go into this. So you don't want to throw away state or data that you need to solve the problem better. And software is a real thing, right? It does not run in an ether created by academia, right? It's a real thing, right? Software is a thing that runs on hardware. It solves a real world problem. And you have to be able to reason about the cost of solving that problem. And as I keep saying, reason must prevail. We must be able to reason about the cost and meaning and explicitness of what it is we're writing in our code. Okay? So what is data-oriented design? In closing, it's three things. It's shifting the focus of programming from code to how it is that we meaningfully transform data. It's a response to kind of the current programming culture that's been engendered, which is that you need abstraction as a tool for everything. And 3, it's redefining the role of the programmer. And the role of the programmer is not to write code. That is not your job. If somebody tells you your job is to write code, they're wrong, plain and simple. Your job is to solve data transformation problems. The code is just simply a tool to do that. It's the wrong frame.